Hey guys, we just talked about vertex form for absolute values, and now we're going to talk about vertex form for quadratics. At the topic part, you can just put quadratics and vertex form. Now, before we get going, let me remind you what the parent function of a quadratic is. Remember, the parent function of a quadratic is f of x equals x squared. Okay, so our quadratic is the parabola, okay, whose vertex is centered at the origin. So let's talk about vertex form of a quadratic. Okay, vertex form of a quadratic function is f of x equals a times the quantity x minus h squared plus k. hk is your vertex, and your line of symmetry, or basically where the parabola looks the same from the left to right, is going to be at x equals h. And this is called the axis of symmetry, okay? Notice that the formula here looks exactly the same, okay? Very similar to our vertex form for absolute value. And we'll talk about it in class, why it looks the same. But I think a lot of you notice with our transformations, it makes sense that would be the same. Also with the shapes, even though the absolute value is a v and our quadratic function is a parabola, they both have symmetry on the left and right sides. So this makes a lot of sense. All right, let's talk about what determines the width and direction. Now, if you already filled in A, you are absolutely right. A determines the width and direction of the parabola. So the next thing we want to talk about is why we use this form. Well, we use the form the same reason why we use the form with absolute value. This form is awesome because it shows the vertex, okay? So vertex form is going to show us the vertex with respect to the parent function f of x equals x squared, okay? So it quickly shows us the vertex with respect to the parent function f of x equals x squared. Okay, let's do some quick review on our transformations. Remember, the parent function of a quadratic is f of x equals x squared. So I want you to take a minute and I want you to pause the video, work through 1 through 7, and describe what happens to the graph of x squared as we change the function. I'm going to work on the odds right now with you just in case you're not pausing. So for those who are actually taking advantage and you're not pausing this, I'm going to do the odds just to get you going, and then I'll pause the video, have you work through the rest of them. So for number 1, what would the transformation be? Well, I'm only adding k to the function, so this should only shift the parent graph up 9 units. Number 3, remember I said I'll do these odds. Number 3, I have 2 things happening. I have a reflection across the x-axis, and then I have a h value. So that's going to shift the function to the left. So I know this would be, the parent graph is going to, and I didn't mean to write an F, it's going to reflect across the x-axis. And then it's going to shift the graph to the left 5 units. So a shift left 5 units. Okay, let's do the last one and then I'll just send you on your own. You are definitely pausing the video this time. 5, I am going to have I have an A here, right? So this is going to be a vertical compression, right? Because think about it, this is 1/3. This is between 0 and 1. So this is going to vertically compress the graph by a factor of 3. Okay, by a factor of 3, or 1/3. And I say 3 because we're going to actually be dividing by 3, but you can say 1/3. And then shift the graph up 2. All right, I'm going to now pause the video. You're going to pause the video, and I want you to go through 2 through 7. All right, take a second and review your answers and make sure they match. Okay, now we'll go down to 7. I want you to review the equation for 7. All right, if Mason reflected the parabola over the x-axis, that should give us a negative. If he translated it 7 units up, my k should be +7. And if he moved it 3 units to the right, my h should be -3. Now I'm going to use this vertex form to graph parabolas. Here we go. Our first step is to remind ourselves what is what. So I'm going to go ahead and write what my vertex form is, which is a times x minus h quantity squared plus k. I'm going to then find my a, my h, and my k. And then I'll use that as a guide for my graph, okay? From there, I'm going to use that guide to help me find the vertex. And then I'm also going to use the guide so I can find my axis of symmetry. With that being said, guys, let's go ahead and find our information. My A for this is 1. I'm thinking multiplication. It's not there, but it's there. It's 1. My H for this is 2. And my K is at 3. Okay, 1, 2, and 3. How cool is that? 1, 2, 3. My vertex then is HK. So my vertex has to be 2, 3. Has to be at 2, 3. My axis of symmetry is at x equals h. So my axis of symmetry has to be at x equals 2. Okay, I'm going to go ahead and put my vertex on my table. I'll plot it right in I'll put it right in the middle, and then I'll sketch this graph. Now the first thing I'm going to do is sketch my vertex. Well, my vertex is at 2, and it's at 3. So it's right here. And now I'm going to sketch my axis of symmetry. I'll use another color. It is at x equals 2. That means that it's a horizontal line right here at 2, which means I should be able to cut this parabola perfectly in half along the line x equals 2. That also means when I start talking about my table values from the left to right, I should have the symmetry at x equals 2. Okay, so I don't have to figure, if I figure out my values to the left, I don't have to replot them in for the right. So what I'm going to do is I'll evaluate when x equals and when x equals 1, sorry, not negative 1. Miss Bennett started writing a negative. But when x equals 1, okay, when x equals 0, and when x equals negative 1, all right? I know that since it's symmetric, it should match up with my values when x equals 3, when x equals 4, and when x equals 5. Okay, so I only need to do one side. I don't need to do both. So if I plug in a 1 into this function, I can see that and I'm just going to do this in my head. That's what Miss Bennett's going to do. A 1 minus 2 is going to give me a negative 1. A negative 1 squared is 1, and a 1 plus 3 is 4. So I know at 1, I'm going to be at 4. 0, if I plug a 0 in there, I would have a 0 minus 2. A 0 minus 2 is minus 2. And a minus 2 squared is 4. 4 plus 3, 7. Okay? And then at negative 1, negative 1 minus 3 is negative 3. A negative 3 squared is 9. And then a 9 plus 3 is going to be 12. This one's not even going to be on our graph, so it won't even make it. All right, so let's sketch these 2 points. Okay, 1, 4. So when I'm at 1, I am up at 4. 1, 2, 3, 4. And the next point I'm going to sketch is 0, 7. So when I'm at 0, I'm at 7. 1, 2, 3, 4, 5, 6, 7. I'm just going to kick 3 because I can't even get it on the graph. Over here, guys, over here is, it's going to be the same type of symmetry. So I can check it if you don't believe Miss Bennett, but if you plug in a 3, notice 3 minus 2 is going to give you a 1. A 1 squared is 1, and a 1 plus 3 is 4. So I'll have this same symmetry on both sides. If I plug in a 4, I'll have this same symmetry as the 0. I should end up with a 7. If I plug in a 5, I should have the same symmetry. I should end up with a 12. So I know at 3, I'm going to be up at 4. And at 4, I'll be up at 7. And did I do, okay, so 3. Okay, and Miss Bennett adjusted her points. I don't know why I had those plotted up there, but there we go. So at 3, or negative 1, I'm sorry, at 1, I'm at 4. Okay, and at 0, I'm at 7, and I have that same symmetry on the other side. At 3, I'm at 4, and at 4, I am at 7. I can now go ahead and plot this, or sketch this. I'm going to use my calculator as a guide to make sure I sketched it right. Okay, let's do the next one. The next one, again, I'll remind myself, f of x is equal to a times the quantity x minus h quantity squared plus k. I am going to find my a, I'm going to find my h, I'm going to find my k, and I look at this graph, I notice A is 1. My H is 0. And my K is -4. So I'm going to figure out what my vertex is. Again, vertex is HK. So I know that my vertex is going to be at 0, -4. My axis of symmetry, so I'll do my AOS, is going to be at x equals 0. Okay, that's x equals h, so it's x equals 0. So I'll go ahead and plot my vertex point, put it right in the middle. It's at 0, -4. And I'm going to plot that on the graph. Okay, 1, 2, 3, 4. So I'm right here. And then I'll go ahead and I'll do a red pen to plot my axis of symmetry. A vertical line, the y-axis. Okay, now I want to have my points to the left and right side. Again, I only need to do one side. I'm going to go ahead and do the left side. -1, -2, and -3. Okay, well, if I plug in a -1 and I square it, I'll have a 1. And then a 1 minus 4 is going to be a -3. If I plug in a -2, I would have a 4. A 4 minus 4 is 0. If I plug in a -3, I would have a 9, and a 9 minus 4 is 5. I know the symmetry for 1, 2, and 3 is going to be exactly the same. I don't have to work that out. Okay, I don't have to work it out. And let's plot our points. So at -1, I'm at 3, or I'm at -3. 1, 2, 3. At -2, I'm at 5. All right, so I'm going to go -2 and then up. Or I'm at 0. -2 is at 0. So -2, I will be right here at 0. And then -3, I'll be up at 5. 1, 2, 3, 4, 5. So -3 is here. And then on the other side, I'll plot my symmetry points. Okay. Which should match my graph perfectly. And then I'll sketch my graph. I'm going to check this with my calculator to make sure I got it right though. Okay, so I'm going to plug this in and just make sure, this minutes graph is not as clean. Let me get that off. Okay, let's try it again. And there we go. All right, so now we have it. In class, we're going to practice sketching these quadratic functions in vertex form.